Hey guys, Mr. Schwannekamp here. Wish I was at school and teaching you instead, but we got to make do with what we got here. So this is going to be our game plan at least for a day or two. Hopefully, we'll see how long it will take. But looking through some different things, your job here today is to complete our notes on motion, and we're going to work through that today. We'll do some chain rule tomorrow and do some practice with that basically the rest of the week. So really 2 lessons this week and then some review from there on out. So hopefully we'll get caught up and we'll be on the right path. All right, so you're getting out your notes from Friday, and we'll continue from there. All right, so this would have been our bell work for today, so let's talk through it. Given this velocity graph, so we identify what it is. When is the object moving backwards? What is going to be true about velocity? If I'm moving backwards, velocity is negative. That's what I'm looking for. Negative velocity would be the key to that. So this is a graph of velocity. So when am I negative? When I'm below the x-axis. So the answer to this question is from 4 to 6. Technically, it'd be in brackets. I'm not super concerned with that right now. When does the object change direction? Well, the object changes directions when velocity changes signs. Because if velocity is positive, it's moving forwards. If velocity is negative, it's moving backwards. So if velocity changes signs, then it changes directions. So when does that happen? Well, here, velocity is positive. Velocity is positive. Velocity is positive. Right there, though, velocity changes from positive to negative. So when t equals 4, it changes direction. Again, its velocity is negative, so that means we're moving backwards, moving backwards, moving backwards, moving forward. So right there at 6 would be the other time when velocity changes signs. When is the object slowing down? The object is slowing down. We talked about this on Friday. Again, this one's a little bit weird. But the best way to think about it is your velocity getting closer to 0 or further away from 0. And so that's more of the understanding than anything else. If we are getting closer to 0, like right there, from 0 to 1, I'm getting closer to 0. I'm slowing down. Right there from 3 until 4, my graph is headed towards 0. I'm slowing down. And then right there from 5 until 6, I'm headed towards 0. Okay? Right here, I'm going away from 0, going away from 0, going away from 0. So in those points, I'm speeding up. The other thing eventually that we'll get to is like right here on this graph. My velocity is going to be positive, and then the slope of that graph, so the acceleration, is negative. If your velocity and acceleration have different signs, I'm slowing down. If they have the same sign, like right there, velocity is negative and acceleration is negative, I'm speeding up. We'll continue working towards that, but eventually that's what we'll get to. All right, let's pick up these notes where we started on Friday, or where we ended on Friday. I think everybody got to the same spot, so I think we should be good to go. Find the velocity when acceleration is negative 2. All right, so find the velocity when acceleration is negative 2. All right, so this is our ultimate goal. This is when it is happening. So I'm given position. What am I going to do with position to find acceleration? I need to find the derivative. So I need to find s prime of t, because that will tell me velocity. Velocity is the derivative. So I'm going to multiply by 3, so I get 1/4 t squared minus 6t minus 4. That is the derivative. That is what velocity is. Cool. I want to know acceleration, so I got to do it again. And so I'm going to find the second derivative of position, which is the derivative of velocity, which is acceleration. All of those things mean the same, so I'm taking the derivative of this. So multiply that, I get 1/2. Yeah, let's color code that. Let's go purple. 1/2 t minus 6. That's my derivative. That's acceleration. Now the question is when the acceleration is negative 2. So what that means is I want this right here to be negative 2. So in other words, I'm going to take that and set it equal to negative 2, because acceleration is negative 2. This is acceleration. I want it to be negative 2. So I'm going to add 6. So if I add 6, I get 4. Then I'm going to multiply both sides by 2. I get t equals 8. So that is the answer to the question. When is acceleration -2? But they asked me to find the velocity. So if I want to find the velocity when that is true, I'm going to take 8 and plug it into velocity. So this is my velocity equation right here. 1/4 squared minus 6 minus 4. So right here I'm plugging in 8, and then solving from there. We could leave it right there. 64, 1/4, that would be 16 minus 48 minus 4. I believe that gets me -36. It didn't give me units. We could easily say, hey, the units are something like meters per second or miles per hour or something along those lines. All right, so again, we found the velocity when acceleration is -2, so we set the acceleration equal to -2 and then plug back into velocity. Example 8, a stone is shot with a slingshot vertically upward with an initial velocity of 50 meters per second with an initial height of 10 meters. All right, so they gave me a position equation, and we're talking about taking a rock. Oh, I'm going to struggle here, but I've got a slingshot. Oh no, this is bad. And we're shooting that rock, and it's going to go up in the air and come to the ground. All right, so imagine that I would throw a rock in the classroom. Not a rock, I would throw a tennis ball in the classroom, but I'm not in the classroom, so we'll have to make do. Find velocity at 2 and 7. So what am I going to have to do with position? To find velocity, take the derivative. I'm going to find v of t. So I get -10t plus 50. That is the derivative of that guy right there. That's a 5, I swear. Cool. Then we're going to find the velocity at t equals 2. So that means I'm going to take 2 and plug it in. I get 30. I'm going to take 7 and plug it in because I want to find the velocity at 7 seconds. That gets me -20. Great. Our job is to explain the sign change. So think about that for a second. Hit pause if you need to. Why does the velocity at 2 have a different sign than the velocity at 7? Well, think about that. If the velocity at 2 is positive, that means I'm going up. And if the velocity at 7 is negative, I'm going down. So somewhere in between 2 and 7 seconds, my slingshot, my rock change directions. Positive velocity, I'm going up. Negative velocity, I'm going down. When does the stone reach its maximum height, and what is the height? This is bad. I should say when. That's ugly. When does the stone reach its maximum height? So think about that. If we take that rock and shoot it upwards, obviously right there is when it's at its maximum height. What is true about the velocity of that rock right there? At least the upward velocity. The answer is it's 0. At a maximum or a minimum, my slope is 0. And so if we take that velocity equation and we set it equal to 0, it will tell me when that rock reaches its top value there. So if I solve that, I get -10t equals -50, t equals 5. So at 5 seconds, it's reaching its maximum height, which makes sense because that's in between 2 and 7 when we said we went from a positive to a negative velocity. Then the question is, what is that height? What are we going to do here to find out what the height is that it reaches a maximum? Well, we know when it reaches its maximum, and this equation right here tells me the height. So all we have left to do here is find s of, oh my gosh, my s's and 5's look exactly the same. S of that, yeah, rewriting it made it way better. -5 times 5 squared plus 50 times 5 plus 10. So I just took 5 and plugged it back into my position equation because I want to talk about height. I want to talk about its position. So then I could just do that. This is -5 squared 25. That's -125 plus 250 plus 10. I get 135. My units would be meters because I'm measuring height. So again, just understanding velocity, when does something reach its maximum height, all those good things. All right, last one. Now we're going to do some calculator practice. So this is important. Again, on our test next, we're going to have some calculator on there. So we want to make sure we know what's going on. So a pendulum is modeled by this equation right here, where S is measured in feet and T is in seconds. Okay, so make sure we understand what a pendulum is. A pendulum is a string with something connected to it, and it's going to swing this way, and then swing this way, and then swing that way, and that way. It's going to swing back and forth. Okay, that's what we're trying to deal with here. So let's break out our calculator. First thing you want to check is your mode. Make sure you're in radians here. If you're in physics class, you're going to go in degrees every once in a while. But here I want to be in radians. All right, I'm going to, in calculus, we're always in radians. We're going to type in that equation, 3 cosine 3x. Type that thing in. It said we want to look on the seconds from 0 to 4. So let's hit the window button. And we want to change the x minimum to 0 and the x maximum to 4. So x and t time are going to be the same variable here. So from 0 to 4, let's hit graph. Cool. There's my graph right there. Find the pendulum's displacement in the first 1.5 seconds. All right, so remember, displacement is the change in position. So if I want to know the change in position, I want to figure out where I'm at and where I'm going. So really what I want to know is S of 0 and S of 1.5. So remember how to do that. The easiest way to do it, I think, is going to alpha F4, Y1. I'm going to plug in 0. Basically, I'm just plugging in 0 into that equation. It's 3. We can look at this picture. Yep, that makes sense. It should be about 3. Okay, we're going to do the other one. So we're going to go alpha F4, Y1. And then in parentheses, I'm going to plug in 1.5. Hit enter. Ooh. Negative 0.632. Remember, we're always going to go 3 decimals here. So negative 0.632. Cool. So those are my two values. What do I want to do to find displacement? Remember, we're going end minus start. So it's negative 0.632 minus 3 gets me negative 3.632. That is my displacement. And again, if it makes sense on my graph here, I started this way, and I'm going to go back to right about there. So since I'm further negative than I started, it should make sense that my displacement is negative. Next question. Find the pendulum's average, let's go with velocity here, but we'll talk about acceleration here in a second. The average velocity. If I want to find average velocity, when we think average right now, we are thinking average rate of change. Okay, in other words, a 2-point slope. So if I want to find the average velocity in the first 0.5 seconds, I'm going to find S of 0, which we know it's 3, and S of 0.5. So second quote, alpha F4, Y1, 0.5, 0.212. If I know position and I find the average rate of change of position, if I find the slope of position, we're going y sub 2 minus y sub 1 over x sub 2 minus x sub 1. If I find the slope of position, that tells me average velocity. That is going to get me my answer here. So I'm taking that number right there, minus 3, and I'm going to divide it by 0.5, negative 5.576. 576. Is that right? 576, sorry. 576. My units would be feet per second, because this is measured in feet, that's measured in seconds. On your homework, it asks for average acceleration. So if you wanted to find average acceleration, what would you need to find the slope of? You would want to find the slope of velocity. All right, hopefully that makes sense to you. If not, ask me questions. All right, let's keep going. Find the pendulum's velocity at 0.5 seconds. Okay, well, we can do that. We want to know velocity, and they gave me position. Remember how to do that in our calculator. We're going to go math 8. Okay, remember, let me do that again. No. Let's try it again. Math, and I'm going to go down to number 8, numerical derivative. So math 8, it's dx I'm going to go alpha F4 Y1, that equation that is my velocity or my position equation, and I'm going to find the derivative at 0.5 seconds, so I'm going to plug in 0.5 right there. I type it in, I hit enter, negative 8.977. And my units would be feet per second, because I took the derivative of position, so I'm going to include a time unit in my denominator. All right. Now it asks us to graph velocity. We'll be able to do this on our own in the future, but for right now, we just got it right there. Let's type it in, negative 9 sine 3t. Okay, so we're going to type in negative 9 sine 3t. Type it in. Let's hit graph. Okay, there's my graph. When does the pendulum change direction during the first 2 seconds? This is velocity. Here is 2 seconds right there. What needs to happen with velocity for you to change directions? I need to change signs, because if the velocity is negative, I'm moving backwards, moving backwards, moving backwards, moving backwards, moving backwards, moving forward, moving forward. Okay, so second, calculate. What would I want to calculate here if I want to figure out when it crosses the x-axis? That would be the 0. I'm going to move my cursor here to the left side. Sorry. Move it to the left side of where I think it hits 0. Hit enter. Move it to the right side of where I think it crosses 0. Hit enter. Hit enter a third time. Boom, 1.047. The other time it changes direction is outside of 2 seconds, so I'm not worried about that one. 1.047, that was going to be my time. And why did we pick that? Because velocity changed signs. And if velocity changes signs, that means it's moving from forward to backwards or backwards to forward. What is the particle's position when S is at a minimum? What is the particle's position when S is at a minimum? Well, looking at this velocity graph, what would I want to know if I am at a minimum? So think about that. When is S at a minimum? When is my ball at a minimum? Well, think about it. This right here is it's moving backwards. It's moving backwards. It's moving backwards because velocity is negative. It's moving backwards, moving backwards, moving backwards, moving backwards, moving forward. So right there is when it's at a minimum, right? So that's the value we want. And if we want to find a minimum, I want to plug it into that equation right there, 3 cosine 3t. So I could do this a couple different ways. We could type back in 3 cosine 3t. We could type that in. All right, right now, and here's the other thing. Think about what we just found. We just found the 0. So if you hit the X button right now on my calculator, that button right there, it's going to pull up that 1.047 number. We do not want to round it if we're using it in another calculator, in another part here. So you could hit X and then pull it up right there. You could also do some storing stuff. We'll wait till later. Now let's do it now. All right, so what we want to do is we want to take the X value that I just found, that 0, and I'm going to store it. So that STO button right there, I'm going to store it as alpha A. So I hit the alpha and then the A button. Now it's going to be saved as the letter A in my calculator all the time. I think we've done that before. I can't remember which class I taught it in. We're going to take that A and we're plugging it into position. So I'm going to go alpha F4. Mine is typed in as Y2. And I'm going to plug in alpha A. And that A value is that 1.047 number. So what is my position? It's -3, which makes sense thinking about this curve. We started at +3. It's a pendulum, so it went all the way to -3, then +3, then -3, and so on. So that's -3 feet. And what did we do? We found S of 1.047. Last question of the day. Find the acceleration at 0.5 seconds. What do I want to do with velocity to find acceleration? We're going to take the derivative. So math, go down to number 8. dx. Right there, we're going to type in our equation. So we're going alpha f4. My velocity equation is typed in as y1, and I want to find the acceleration at 0.5, correct? Yep, 0.5, type it in, hit enter. Negative 1.909 or negative 1.910. That is in feet per second squared, because I just took the derivative of velocity, which is acceleration. So we found v prime at 0.5. All right. I know that's not perfect. Hopefully you're getting some of that, and we'll continue to get better once I get back and we'll understand it more. Now that we're done with this in class, you've got some homework that I want you to get done. But before you do that, I want you to do the quizzes that I've attached in the Schoology folder. Just that way you get just an that way you just practice it a little bit. I want to see how you did, but that way you get some instant feedback. Hey, I'm doing it right, or no, I'm not. All right. Let me know if you have questions. Reach out to me on Schoology. I will gladly answer whatever you have. Thanks, guys.